Okay, these are for Friday's lesson notes, and it's classwork, meaning if you have this paper with you or a piece of binder paper, we're going to go through the whole thing together today. So at the end of this video, it'll be a little bit longer, but at the end of this video, you'll have everything done. So get yourself ready with your paper and your pencil. Pause this if you need to get it, and we will start. So we're putting it all together, and this is where we're making sure we know all of our formulas. And first of all, our slope formula, we have m, is the letter we use for slope, and we subtract our y's, so we write y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, and that is the slope for the formula for a slope. The slope-intercept form, this is the form of a line you probably learned in Algebra 1, which was y equaled mx plus b, where m is the slope and b is the y-intercept. The standard form is another format of the line where we have some coefficient a times x plus another coefficient times y, and that's going to equal a constant, and that is your standard form of a line. The point slope, this is the new one that we have been learning in this coordinate geometry unit, and this is when you have a point and slope. So we have the letter y for the equation minus, and I like to say it with the k is equal to slope times x minus h. And this is where you have the point h comma k and the slope m to write that equation. The slopes of parallel lines, are equal. And describe the slopes of perpendicular lines. They are opposite reciprocals. An example would be if my slope was 3/5, then the perpendicular slope would be negative 5/3. Or another example, if my slope was negative 4, then my perpendicular slope would be positive, because I change it from negative to positive, and this is like 4/1, so this will be 1/4. So there's some examples of perpendicular slopes. All right, we're going to go on to the next page where we're going to have some problems to work on. So here we have some problems to work on. We've done problems just like this throughout the week, and we're going to determine whether or not they are parallel, perpendicular, or neither. So we're going to compare their slopes. So the first thing we're going to do is for the line AB, we're going to look at its slope, which is, we subtract the y's, 4 minus 5, and we divide that by the change in the x, negative 8 minus negative 11, negative 8 minus negative 11. 4 minus 5 is negative 1. Negative 8 plus 11 happens to be, that'll be 3. So we have negative 1/3 for the slope of the line AB. Now we're going to find the slope of line CD. And the slope of line CD is going to be the slope of that, and it equals the change in the y, negative 4 minus negative 7, over negative 1 minus 8. And negative 4 plus 7 is 3. Negative 1 and negative 8 is negative 9. When we reduce that, that's going to become negative 1/3. They have the same slope, so they are parallel. I'm going to have you pause the video, try to do a couple of these problems, and then when you come back, I will have these problems done out here for you, so you will see what they are. But you should pause the video at this time and attempt to do problems 2 and 3 on your own. So you pause it. Okay, so we're back. Hopefully you've done these 2 problems, and in problem number 2, we found the slope of line AB was 7/4, and the slope of CD was negative 4/7, which makes these 2 perpendicular. In number 3, in both cases, my denominator would have been 0. That's called an undefined slope. It means that we've got a vertical line. So both of these are vertical lines, which means they are parallel. Okay, so now let's move on to problems numbers 4 and 5. I'm going to do 4, then you'll pause it, you'll do 5, and then you'll see the answer out. Okay, so in number 4, it says we've given these points and this other point M. Find the values so that they are parallel. To be parallel means their slopes have to be the same. So we want to look for the slope of JK. So the slope of JK, we know that its slope is going to equal, so we're doing 7 minus negative 18 becomes plus, addition problem, 2 minus negative 8, so 2 minus negative 8, and that's going to give us 25 over 10, which is the same thing as, I could write that as 2.5, and that maybe will be a little bit easier, but I know they're both divisible by 5, so I'm just going to write that as 5 halves. So I've got 5 halves for that one. For the next point, for the slope of LM, which is what we need to find now, LM, we know that the slope is going to be, we're going to take our y's, so 4 minus 9, and that's going to be over negative 1 minus, sorry, we started with this one here, 4 minus 9. So we have to do x minus negative 1, which would be x plus 1. Well, this is 4 minus 9 is negative 5 over x plus 1. So we're trying to find the value of x. Well, I know that these two, this one here and this, these have to equal each other. So I'm going to write that out. I'm going to have 5 over 2 is got to equal negative 5 over x plus 1. So if this is true, I'm going to cross multiply. So that means I'm going to have 2 times negative 5, which is going to be negative 10. And that's going to equal 5 times this x plus 1. I'm going to multiply both parts of this by 5. So 5 times x and 5 times 1, which is going to give me 5x plus 5. We're going to subtract 5 from both sides so that we have 5x equals negative 15. Dividing both sides by 5. Sorry, I've got to run out of room here. Divide both sides by 5, and negative 15 divided by 5 is negative 3. So my answer is x equals negative 3. So the goal here was I found the slope of one of the lines, I found the slope of the other, and since they are parallel, I set them equal to each other and solved for x. Now you're going to do problem number 5. I'm going to have you pause this, do the same process. The difference is it says that they are perpendicular. It's kind of hard to read that there, but it's saying that they are perpendicular, which means instead of setting them equal to each other, you're going to flip one of them and negate it and then set them equal to each other. You try that, pause the video, try it, and then come back and I will show you how I did it. Okay. Okay. So here I've done the problem. The first thing I did is I found the slope of EF, and we found that it's an expression. We don't get a number. We get 5 minus y over 12. We found the slope for GH, which when it's simplified, we got 4. But I want the perpendicular slopes that's there. So instead of 4, I'm going to be setting this expression up here equal to negative 1/4. So here I've done it. The perpendicular slope is equal to the other slope. So this is how I know they're going to be perpendicular. Cross multiply, and I get negative 12 equals 20 minus 4y. If I subtracted 20, I get negative 32 equals negative 4y. Dividing by negative 4, we get y equals 8, which is the answer there. Okay. All right. The next group of problems, these next 4 problems, it's to determine whether they're parallel, perpendicular, or neither. So we want to find the slopes. Now, I want to remind you that when the equation, I had it in one of our previous lessons, that when it's in standard form like this, when it's an ax plus by equals c, that our slope is the same thing as, because we would have subtracted 6x, we would have subtracted that. So that's going to be our negative a divided by b. So we're going to get negative a divided by b. So I know that for this problem right here, instead of having to solve it for y, I'm going to use that little formula that helps me say, oh, I'm just going to do negative 6 divided by 10, which reduces to negative, because they're both divisible by 2, 3/5. So that is the slope for that equation. For this one here, once again, I'm going to do the opposite of what's in front of the x. So this slope is negative 5 divided by what's in front of the y, which is negative 3, which is positive 5/3. So when I compare this slope to this slope, we can see that they are opposites. One's positive, one's negative, and they are reciprocals. So these are perpendicular lines. I'm going to use the same method for finding my slope as I did on this problem here. In front of each of these is a 1, so I'm going to do the opposite of what's in front of the x, negative 1, divided by whatever's in front of the y, which is negative 1, which means the slope is 1. So for this first line, the slope is 1. For this one, we're doing the opposite of what's in front of x, negative 1, divided by what's in front of the y, which is 1. And so the slope for this one is positive 1. Oh, they have the exact same slopes. Both of them have a slope of 1, which means they are parallel, right? I want you to attempt to do problems 8 and 9 on your own. So once again, you're going to be pausing the video. Do these problems, and when you're done doing the problem, unpause the video and check out what I have for the answers. Okay, so pause. Okay, so those two problems, they were a little bit tricky for what they were. This one here was following that same method I just showed you, that I did the opposite of x, what was in front of x, negative 1 divided by negative 5, which is 1/5. Here, well, you can't do the opposite of what's, because it's not in standard form. In fact, all you would do here is divide by 10 to solve for y. So your slope would be 2/10, which reduces to 1/5. They're the exact same slope, so they are parallel lines. And number 9 is real tricky. X equals 5. If I asked you to graph that line, you would go over to where on the x-axis there was a 5. Whoops, it's x-axis. And you would put a vertical line up and down. That is the line x equals 5. Similar, this one is at x equals -2, which would be over here at -2, and another vertical line. They're both vertical lines, and therefore they are parallel. So x equals, and the number, x equals 7, x equals 12, x equals 35, x equals -52, those are all vertical lines. If, on the other hand, I had y equals 7, now we're talking about a horizontal line, a line with a 0 slope. So anytime I have y equals, so y equals 7, and say y equals 1, well, now I would have, again, a pair of parallel lines that are both horizontal. X equals our verticals, y equals our horizontals. All right, let's look what's on the next page. We did have 3 pages of our work today. So here, this is the topic for writing equations. And so here we have write an equation that passes through the point -6, 1 and has a slope. Make sure that we are writing in slope-intercept form. Y equals mx plus b. We had other homework this week in the same manner. So we start off by writing this in the point slope form of a line. Y minus the y of the point, 1, equals the slope, and it says it has a slope, and it's hard to see on this camera, but that says 1/2. So it has a slope of 1/2. And then we're going to have x minus that -6. So we've got the problem. That is an equation of a line, but we want to distribute the 1/2 to both of those, and we'll have y minus 1 equals 1/2 x. 1/2 of 6 is 3. Then we're going to add 1 to both sides. When we're finished, we have y equals 1/2 x plus 4. And there is the equation of a line that goes through the point -6, 1 and has a slope of 1/2, written in slope-intercept form. Pause the video, do problem number 11, and when you're done with problem number 11, unpause and check your answer. Okay, so in problem number 11, the first thing was they didn't have a slope in this problem. So we had to figure out the slope by using the slope formula, and we found the slope was -1. Then you pick either one of those 2 points. Now it'd be interesting if you picked the point, -2, 6, you would have still gotten the same end result as if I picked this point 3, 1. So I'm doing this point slope form, y minus 1 equals -1 times x minus 3 using that point. And then solving for y, I end up with this equation in slope-intercept form. And again, if you use this other point, you would have gotten the same result. Right? Let's look at number 12, problem number 12. Problem number 12 says write a linear equation that is parallel to the line below and passes through this point, which means we're using the concept of parallel to find this slope. So here, I'm going to look at the rise. I can figure out what these coordinates are, but I'm just going to look at the rise, which is 1, 2, 3, 4, 5, 6. So it went up 6 units this way, and then went over run was 2. So my slope is 6 divided by 2, which is 3. And since it's parallel, this is the slope I'm going to use with this point. So I've got y minus -13 is equal to the slope times x minus -4. We're going to distribute that 3. We end up with y plus 13 equals 3x plus 12. Subtracting 13 from both sides, we end up with, in slope-intercept form, y equals 3x minus 1. And that is the equation of the line that is parallel to this one. We could graph it, and then we could see that it has a -1 here, and it goes up 3 over 1. And then we could connect those points. And hopefully you can see that those are parallel lines. I'm not sure if I did my ruler exactly right, but those would be parallel. Number 13 says write a linear equation that is parallel to this one and passes through the point. Once again, we need to find the slope. To find the slope for this one, it's in standard form. I've got ax plus by, so I can do the opposite of what's in front of x, so -5, divided by what's in front of the y, which is 2. And there's your slope. We want parallel, so we want the same slope. And here's our point. So we've got y minus -9 is equal to -5/2 x minus 8. We're going to distribute that 5/2, and we're going to end up with y plus 9 equals -5/2 times x is -5/2 x. -5/2 times a -8, well, that's going to become positive. 2 goes into 8 4 times, so 4 times 5 is 20. And then we're going to subtract 9 from both sides, and we're going to get y equals -5/2 x plus 11. And there is the equation of that line. Okay, I'm just trying to get something on the computer here. All right. We're going to move on to problems 14 and 15 and 16, our last 3 problems here. What I want you to do is, it's the same concept. The difference here is perpendicular. So remember, when you find a slope, you're going to find your slope, and I want to know what the perpendicular slope is. And this is the one you're going to use along with this point. So I want you to do that problem. Same thing here. You're going to find the slope of what is given, and then I want you to find what the perpendicular slope is, because this is what we're going to use with this point to write the equation of a line. So pause the video and then come back and check your answers. Okay, so here's the answers that I have. In problem number 14, the slope of that line is -4, so the perpendicular slope is +1/4. Then we use the point, and then we distribute and simplify, and we get y equals 1/4 x plus 9. In problem number 15, I did -2 divided by -5 to find my slope, since this is in standard form. The perpendicular slope, since this is 2/5, the perpendicular slope is the opposite, which is negative. And then we flip it 5/2. So this is the slope we're going to use. Here it is with the point y minus -9. Simplify equals -5/2 times x minus 2. Simplify it, and we end up with this equation. And this is the equation of line that is perpendicular to the one given, and it goes to the point to -9. So we have our last problem. And it says, RS is formed by these 2 points. If line K is a perpendicular bisector, write the linear equation for the line, for line K. To be a bisector, we know it has to go through the midpoint. So that's the first thing we want to find, is we want to find the midpoint of RS. Okay, it has to be a segment. You can't have a midpoint of a line, only a midpoint of a segment. The midpoint is always, you add the x's, you're taking the average. So you're going to add the x's, -2 and 10. So -2 plus 10 and divided by 2. That's the average of those two x's. Then the y's, whoops, no, I did -2 and 10. And then the y is -10 and -4. So I have -10 and -4. I got mixed up because I both had -10s in them. And we're going to divide that by 2. So -2 plus 10. Here we go. All right. So this is going to give us our midpoint. And this means our midpoint is, this is going to be 8 divided by 2, which is 4. And here we've got -14 divided by 2, which is -7. So this is the point we're going to use. And we want it to be perpendicular to this segment. So now we need to look at RS and find its slope. The slope, now we're going to subtract our y's. So -4 minus -10, -4 minus -10, divided by 10 minus -2. And we're going to simplify that. And when we simplify this, we get 6 over 12, which is 1/2. So if this is the slope of RS, we want the perpendicular slope, which is going to be the opposite, since this is positive, negative, and the reciprocal, which is 2. This is the slope that we're going to use with this point. So we finish this up by writing the equation of the line, which is going to be y minus -7 equals the perpendicular slope, -2, times x minus 4. We need to distribute, collect, subtract, and do all that. Pause the video and work on it yourself. And then when you come back, I'll have the answer. So pause the video. And there you have it. The final answer, y equals -2x plus 1. So as long as you did all of this along with me and you got the whole thing done, you have done both your notes and your classwork assignment for today. And that means you don't have any other work to do over your spring break. When we come back from spring break, we are going to start a review unit on quadratics, those parabolas, which is what we did a little bit earlier in coordinate geometry. So we're going to kind of go back to some of the topics we did in earlier in coordinate geometry, that of parabolas and quadratic equations.